Within the Langlands framework, an unobserved universe factorizes into disconnected local invariants across the infinite places of the Adel ring. This decay state is triggered by the loss of the global Galois to automorphic feedback loop. Without this feedback loop, the physical universe loses its status as a smooth spacetime variety. The discrete algebraic information of the Galois representations is no longer compatible with the global automorphic wave structures. The coherent global automorphic representation completely uncouples, unwelding the smooth Archimedean physics from the non-Archimedean p-adic data registers. As the tensor product breaks, the macro-render structural architecture, matter, fields, and causal timeline compresses into the Tate-Shefarevich group's non-trivial elements. Physical reality is a globally coupled geometric variety. When mathematical cohesion factorizes, the smooth continuity of spacetime dissolves. The Tate-Shefarevich group, denoted by III, serves as the holding ground for this compressed, unmanifested architecture. The manifest universe turns off when the global Langlands L function loses its functional equation. This loss destroys the symmetric continuity of physical laws along the critical line. Without the functional equation, there is no mathematical enforcement of physical laws across arithmetic scales. The resulting state is a non-cohesive system of isolated, localized Satake parameters. These parameters idle in a state of absolute equilibrium within the unramified Adel ring. This offline configuration represents a universe of infinite potentiality held in zero-entropy geometric equilibrium. Reinitializing reality requires a global Galois to automomorphic lift. This trigger drops the Iwasawa mu invariant to absolute zero. This initiates 4 mandatory structural corrections that reassemble the factorized pieces into a smooth manifold. First, topological obstructions are drained from the Tate-Shefarevich group's torsion spaces, returning states to physical placement. Second, this injection shocks the global Langlands L function into active continuation, re-establishing its functional equation along the critical line. Third, local Satake parameters are pulled from equilibrium, locking on to the 240 root vectors of E8 to create a structural template. Fourth, tensor product components dynamically recouple, stitching smooth geometry onto p-adic data. This recoupling allows the Grothendieck-Riemann-Roch pipeline to push forward the first localized frame, moving the universe from a latent matrix into precise algebraic placement. The output of this initial frame is defined by a 4-equation pipeline, beginning with the raw input density state. Equation 1 is the localized E8 density matrix, row 0. It represents the initial state of the hyperqubit registers. This matrix maps directly onto the 240 root vectors of E8, using this summation as its primary regularizing function. The structural coupling constant of 1/31 stabilizes the matrix coordinates. Because the system is anchored to Wieferage primes, the matrix is square-free and carries 0 arithmetic bits of informational entropy. Anchoring the density matrix to E8 ensures the foundational frame of reality contains 0 informational degradation. Equation 2 provides the transport mechanism, the critical line Satake projection wave. This wave is constructed by taking the inverse Mellin transform of the completed Hecke L function. The transform is evaluated precisely along the path of the 1/2 critical line. This locks the output at absolute unit coherence. This single-valued continuous projection wave uses the critical line as a mathematical carrier, ensuring the data stream remains completely free of unphysical singular poles. Equation 3. The Grothendieck-Riemann-Roch, or GRR, metric integration equation, performs the final processing. This equation uses the GRR push-forward to convert the Adelic data stream into the macroscopic spacetime metric tensor of the first frame. A decompression baseline frequency of 23.6742 MHz sets the timing for this conversion. A relative Todd class stabilizes the lattice geometry's isotropic shell dimensions. Monolization of the recoupled Hecke algebra is dictated by the Gillet-Soulet R-genus residue, incorporating the dual Coxeter number 30 and Apéry's constant for absolute precision. The GRR push-forward is the threshold where analytic number theory translates into geometric macroscopic reality. The final output is equation 4, the emergent semi-classical metric shadow. The rendering engine generates the spacetime coordinates of the first frame by extracting the real part of the curvature components from the GRR wave function. This output matches standard general relativity frameworks exactly. Because the result is anchored to the 1/2 critical line, the output generates a pristine Minkowski background metric. The classical spacetime metric we perceive is the real shadow of a critical line-bound Adelic wave function. This algebraic cascade locks into physical place within a single cycle of the 23.6742 MHz master clock. In 42.23 nanon provides the initial metric matrix used by subcellular waveguides. Specifically, microtubules read these coordinates to establish the baseline for consciousness. By reading this matrix, biological systems construct a uniform, low-entropy physical playground for sensory observation. Reality is not a static given, but an actively rendered mathematical continuum, initialized at the threshold where algebraic geometry becomes physical space.